Hello, everybody. My name is György Demarcsek, and today I'm here to tell you our little story with AppArmor. So, why is AppArmor at all interesting? If you use AppArmor properly and you take care of it, and you really put in the effort, then it can be used to immunize your applications against their own vulnerabilities, known or unknown vulnerabilities. And this is why it was kind of interesting to us. But let's first look into what it is actually. So just a little introduction. If you know what SE/Linux is, then just take out a lot of features and a lot of complexities, and then you will end up at something like AppArmor. So you have a process running somewhere. It is trying to make a system call, and AppArmor basically hooks into the system calls via the Linux security module framework. Example, any kind of file operation, network operations, obvious execv, and of course signals, ptrace, actually quite a few. And then what AppArmor gonna look up a centralized, like a central policy, a profile for that process identified by the path of the executable. And it's going to ask this profile, okay, is it okay for this process to do the system call? So basically the profile is a whitelist. It tells what your application is supposed to do, what it can actually do. And of course, if based on that profile, that application just cannot make that call, then it will deny it, and your app will receive a permission denied error or something like that. So that's like the Cliff Notes version. But the story, I mean, our story with this begins somewhere else. So I haven't told you anything about Prezi yet. Prezi is this. I'm presenting right now with Prezi. It's basically an online presentation software that gives you this zooming interface, and it we believe at least it's a better way to visually communicate, because it gives you kind of a spatial impression of everything. And one of the features in Prezi is that you can upload a video file and actually embed it into your presentation. So let me show you. Actually, I prepared a little demo for this. Oh, sorry, just one more thing. This whole thing, this video upload, is served by a microservice written in Python. And it will actually take your video, does some processing on it, and it's gonna put it into the Prezi. And I made a little replica of this service so that I can demo you a really nice thingy about it. So this is basically the user interface of that service, whatever. And I'm gonna say, okay, let's scale my whatever video I'm uploading. It doesn't really matter. And I'm gonna upload this cute kittens.avi, of course. And the conversion is happening in the background. And this is really what used to happen when you embedded a video to Prezi. So let's see. Ooh, doesn't really look great. I don't know if you had a chance to spot it, but this is exactly the content of the etc password file. Okay, so this happened. I mean, one day we receive a bug bounty submission. We have a bug bounty program. And it was telling us that, hey, this works. I mean, they could actually read the password file from the nodes that were running the conversions for these video files. So just for, I mean, I'm pretty sure you see what was happening. This is just a recap of this. There was a CVE about this. So the issue was in FFmpeg's HTTP live stream processing feature. It basically did not properly validate the URLs, and it allowed to access local files as well instead of proper HTTP requests. So that was the CVE. And the funny thing is that CVE was released 3 days after we received the bug bounty submission. So we were a bit surprised and also impressed. But of course, we had to do something, right? One of the things I want to add here is that, of course, we did a lot of log digging and looked into all the FFmpeg logs. We have actually pretty good logging about what FFmpeg does in the background, and we found hard evidence that nobody could exploit this to extract any kind of user data. So this did not escalate into an actual incident. Of course, we found the researchers' attempt, which was great. So, this happened, but of course we were okay. This was not escalating to an incident, but we still had to mitigate the issue, right? So we asked the question, what the hell should we do? And there were a bunch of options. Like patching FFmpeg or containerizing FFmpeg with Docker, siege, root, whatever. And we found both of the options pretty slow. And I think this requires a bit of explanation. So we handle all of these valid bug bounty submissions as potential incidents. So, and for incident response, we have an SLA that is measured in the order of magnitude of hours. And patching this thing, rebuilding these services, redeploying it to a bunch of EC2 nodes, all the stuff, validation, testing, whatever, all the process, it would have taken us days. So I think this gives you the context why we found these two options slow. But there was AppArmor. We already had, okay, so I'm cheating a bit here because we already had some basic infrastructure around it, and it was not the first time we used it, but it turned out to be like a viable option. I mean, we could do mitigation with AppArmor like in an hour or so. So let me show you what we did. We created this profile for FFmpeg. It basically says, okay, it's okay to execute the binary. It can read the uploaded video files, and it can write to the directory where we store the converted video files. And basically that's it. Some common stuff is there that is basically often needed by all processes, basically. So, and that was it. I mean, we came up with this. Now you're wondering, okay, but you could still read other people's video files, but luckily it's not the case, because then you would have to guess the file name, which you will not be able to. So that was our mitigation back then. And of course, I'm not trying to say that it's a bad idea to patch. It's always a good idea to patch. But as I said, because of our SLA, we wanted to find a quicker solution, and then later on we of course moved on with patching FFmpeg to the latest version. But this was pretty new stuff there then. So and then I thought to myself, why not take this a little bit further? I mean, yeah, now FFmpeg was vulnerable, but this was a Python web service. There could have been any vulnerability inside Python or any Python library that we were using. And of course, we do not really know. So why not confine the entire web service with AppArmor? We have a really good idea what this web service does on a system call level. We can easily come up with a profile. Like it's really not that difficult. So I started to experiment and came up with this thing. So what you can see here is basically two profiles. The first one says that it's that the web service can read its configuration file, and I created a profile that kind of profiles common G-unicorn applications. I don't know if you know about G-unicorn. It's basically a Python web server, and yeah, the last line says that it is allowed for this service to switch from this profile to another profile. And this is quite important, because this is how AppArmor makes it possible to do privilege separation. Right now, it kind of makes sense to have like two phases for the application. One initialization phase, where it's okay to access the configuration file, and then a phase when your service listens to client requests. And then, in that profile, it's not okay to read the configuration file, because we already read the secrets from there. You see what's happening? So it means that when the process is in this phase, then no matter if an attacker can find a vulnerability by which it can read local files, he won't be able to access the configuration file, which of course may contain some sensitive secrets there. And of course, then when it started to listen to these requests, it must be allowed to execute FFmpeg, but only confined with the profile, which I just showed you earlier. So yeah, that's the basic idea. Of course, you will have to tell AppArmor somehow from your application that you want to make this profile transition. So for that, you will have to use libappArmor, which is basically the user space library for doing this kind of stuff. It has a Python binding compiled by Swig, and it's basically one line of code, really. I mean, it's really not that difficult. You read all the config files, and then you switch to a profile where it's no longer allowed to read the config files. Now demo time again. So I have my little service here, and I'm actually on the node that is hosting this thing. And I'm going to say, okay, AppArmor, please enforce the profile for this web service. I call this profile vulnerable. Never mind. So let's try our little exploit again. I just enforced this profile for AppArmor. And I'm going to upload my specially crafted cute kittens AVI. I know, it doesn't really matter, but let's change the resolution as well. And it is doing the conversion again, now with the profile I showed you in the previous slides, and AppArmor working in the background. So let's see the result. Oops, no more password file there. So it works. But of course, I mean, I showed you that profile there. It's not trivial to come up with this. It's not like, I mean, you will definitely have to have some tooling around it, especially if your service is a live thing. So we started to come up with some infrastructure that supports developing these profiles by basically letting you know what the hell is going on inside AppArmor. Luckily, AppArmor has really good integration with the audit subsystem, so you can find all the logs about access denials in the audit logs, and you can basically just parse it. We do log stash, so it was pretty easy. I mean, I know it's not readable, but it will be up in that repository I just linked on the other slide. And of course, you can stream all these logs into Elasticsearch, and then you can do some visualization in Kibana, where you can see all the system calls, all the operations that were denied, all the profiles, all the objects that the applications are trying to access, and of course the individual events. And this gives you like live feedback on what is happening and how good your profile is doing. And of course, if you're really advanced, and we do this at Prezi, already, you can build some alerting around this. Whenever AppArmor says no to some system call, you can, for example, trigger a Slack alert and tell the security team. This is pretty important because this tells me that either there's a new vulnerability we did not know about and someone is trying to exploit it, or our profile is not correct and it's not allowing some action for that service to carry out, even though that action is legitimate. So these are the two things, and both cases and both pieces of information are really useful. So, yep. A lot of things was said. I want to give you a little recap, like a little summary of what we learned during this whole process of playing with AppArmor. So one thing is that you probably shouldn't confine all the processes. I mean, even if you have all this tooling around it, it probably doesn't make sense to create a profile for every single thing that you have. Instead, you would probably want to do a proper risk assessment approach and see what the risk of an arbitrary command execution or an arbitrary file read can be on that machine, because it might not be that critical in all the cases. Yeah, so probably you don't want to go crazy and start confining everything. But it is, as I showed you, a good idea to integrate it with your existing monitoring system, because this is really the thing that will make AppArmor a viable tool for your developers. And it really has to be the developers, because the profile describes, so the profile depends on how your application works under normal circumstances, how it is supposed to work. So it really lives together with the code. So actually it could be regarded as part of the code. And yeah, so because the code is understood by the developers, you really have to give them some tooling that makes it possible for them to use AppArmor as an additional line of defense. On the other hand, testing it is not, it's far from trivial. I think it starts from having good acceptance tests. Actually, this is what we did when the FFmpeg thingy happened. We basically started to iterate on the profile, always updating it, adding some extra permission, and then running the acceptance tests and see where it breaks. And then we iterate again and again and again. And in the meantime, we could monitor this whole thing on Kibana, as I showed to you. And finally, AppArmor is just as good as your profiles. I think this came up earlier in Apostolis' talk, that basically profiles are a whitelist. If you say in a whitelist that it's okay to do anything, then you are not better at all, and you are just adding complexity but not security. I mean, that doesn't make too much sense. So it really has to be maintained. And it's not snake oil. I mean, it's not like your security solution for everything. Yeah, so that was kind of it. Questions?
No question.
What about SE Linux in comparison?
So we considered SE Linux as well, but we found that the cost of SE Linux for an organization like us, like Prezi, which is like a mid-sized organization, is just way too high. Because of the extra complexities, because of the whole difficulties around SE Linux. I mean, I know that there are definitely some advantages. It has a lot more features. It has a lot better documentation. But if we really want to distribute this and ask developers to actually develop and maintain these profiles, then AppArmor is a lot more viable option because of its simplicity. than SE-Linux.
So what you just mentioned about developers creating the profiles, do you think that's realistic? Or do you think maybe another approach might be to kind of enforce a profile and say the application needs to conform to this? Like, which approach do you think would work better? So when you mentioned about the profiles and having developers create them, do you think that's realistic? Or do you think maybe it might be better to kind of give them, say, your application needs to work with this?
Thanks very much for that question, because I actually wanted to point out one thing, is that the idea of using AppArmor, in this case with FFmpeg, it came from a developer, one of our developers. So I was actually really proud, and I was like, okay, so people are already aware of this, and they are okay with using it and trying it out with all this extra tooling. So yeah, based on that, I think it's totally realistic. Of course, your profile will not be like at any certain time fully up to date and perfect, but we are probably good with not perfect but almost perfect. So I mean, it's still pretty good.
Thank you very much. It might be the case that developers are very relaxed about permissions. And also we have to take into account that with each update of an application, things might break and not work anymore. So I will advise also to put one point about put it on monitoring mode for the first part of installation, first few days, I would say a week. And then with every major update, depending on how bold our developers with major and minor updates, have a lookout about things that get denied just for maintaining operations.
Yeah, thanks for pointing that out. So AppArmor has a complaint mode where it only logs what it would deny in enforcing mode. And of course, I did not say, but quite obviously we did not, when we were fixing FFmpeg, we were not running it in enforce mode like in the beginning. We were iterating it in complaint mode. So because of exactly the reasons you were mentioning, because of preparing for possible downtime and outages and just breaking the whole thing, we really had to take a careful approach there, but it's totally feasible to do that. So thanks for pointing that out.
Yeah, thanks for the talk. I have a question. So in the first demo that you did with FFmpeg, you created an AppArmor profile to harden the file system and specify specific locations that it has access to, and you allowed access to the uploads directory only and another directory. Now this was working for you guys because the file names in that directory were using UUID as a file name, so the attacker, possible attacker, could not identify, could not guess the file name to access it, correct? What would happen if you didn't use UUID and you had other types of file names like sequence? I don't know. Would it work?
So yeah, if you take this perspective, then basically this only worked because there was no way for the attacker to list the directories, right? Because if we can look up any file name, then even the UUID thing will not really save us. So actually, that is also something that you can control with AppArmor. So you can say that you cannot list this directory. So that's what you can do. And of course, there is, as I mentioned, the issue that these paths might change. The application might change how it handles these file names and everything. So this is why you kind of have to adapt your profile to the application all the time. Yep.
Just Just to clarify, my question is, what if the file names are predictable? That's my point. Okay, you cannot list the contents of the directory. What if the file names are predictable? Like 1, 2, 3, 4. Okay, so using parameter tampering, I can get any file I want.
So if the file names are predictable, then AppArmor will not save you because it has no idea of the context in the sense that, of course, it doesn't know about any kind of authorization that you might implement on the application level. So it speaks system calls, it speaks file permissions, it does not speak user or stuff like that because that's like a much higher level concept. So you cannot really do that.
Anyone?
Will you publish, for example, the profile generator or the ELK configuration on some GitHub or?
Yes. I mean, even the application. I mean, this little Python thing is already up. The profiles are already up. I think the logstash config is not in that repo yet, but I can push it, of course, and I will. Yeah, sorry. So that was in the. Oh no. Nah. Come on. So this is the link. Sorry. I don't know what's the good format of sharing these after. But this is the link.
What if I'm running my services on Docker, for instance? What would be the benefit or the added value of AppArmor in this case?
So the thing with Docker is that, so with Docker you can do all this without AppArmor. The thing is that all the security-related features around Docker tries to build on security in depth. So they're providing a bunch of security-related technologies, and they might be redundant. They might do the same thing. So, for example, with some volumes and seccomp and capability restrictions and R limits, for example, you can do the same as with an AppArmor profile. But the idea behind this model is that you might want to use some technologies for a specific use case. You might want to combine these technologies just in case any of these might fail or not up to date or not correctly configured. So that's really like just taking a security in depth approach. And actually, Docker really supports AppArmor pretty well now. Of course, the Docker daemon itself has an AppArmor profile, and it has a pretty good default AppArmor profile for the containers, which you can start with, and then you can iterate on that.
Okay, so Joey, thank you very much for your talk.